Students, now let us revisit the common facility layouts. You would have known those facility layouts from your course in operations management. Let us revisit it. We have a product layout. A product layout is a production facility that are arranged along a serial line or a serial manner to represent the flow of the product through the various facilities. So in a product layout, the different type of facilities or different type of departments, the product would actually flow in a serial manner, in a sequence. When we say it's in a sequence, what does it mean? If a lathe operation has to be performed before some finishing operation, then the lathe department would come before that. If cutting has to be performed before stitching, then cutting department would be coming and then stitching department would be coming in a sequence with the cutting department. So that would be the product would first, or the raw material would first go to the cutting department, and then it would go to the stitching department in a sequence. For instance, if the operation sequence requires a lathe, a milling machine, some heat treating and painting, then the production line will first have the lathe, then the milling machine, followed by the heat treatment shop and the paint shop. Then another common layout is the process layout. In this layout, production machines are grouped based on the function or processes they perform. For instance, all drilling machines are grouped and put in one place, and all welding units are placed together in another spot. What does it mean? If any organization actually follows the process layout, what will happen? The product would flow. It doesn't necessarily would be in a sequence. Rather than that, the raw material or your semi-finished product would be going to that section or that department, rather than you would be arranging them in some serial manner. So the facilities or the departments would be fixed, and as per the functionality, the product would actually move there. This layout actually support job shop type production units where product variety is very high and production volume is low. You would know that with this type of a layout, the material handling actually becomes very cumbersome or very tedious, in a sense that it requires more traveling. There would be some products that would require that function, let's say at the end, that require, let's say, the painting function. There would be some product that would require that painting at the start, and there would be a product that would require to do that painting at the end. So you cannot determine the sequence of it, but as per the variety of the product would flow. The product would actually go to those departments. So the volume would not be that high because of higher material handling. Then we have a fixed position layout. This layout is actually appropriate when the product to be manufactured is too heavy and large to be moved around in a plant to go through the series of facilities. In this layout, the product stays in one location, and the resources such as workers, material, and tools are brought to its location. It's a fixed position layout. Machines are too heavy to be moved from their place. In a product layout, in a process layout, it is possible to move the machine, but in a fixed position layout, it is not possible because of the weight of those machines or the volume of those machines. You cannot move them every time, or you cannot arrange the layout dynamically as per the type of product. So in this case, the workers or the resources or the product has to move to that machine, rather than the machine would be going, or you are actually arranging the machines as per the product layout. Then we have an important type of layout that was cellular layout, also known as group technology. This layout stems from the concept of group technology. GT is a philosophy that capitalizes on the similarity of recurring activities. Cellular layout is an application of GT where machines are grouped in cells based on their capabilities to process a family of parts. So what actually happens, different type of machines could be in a group or a cell, and they would perform the function either sequentially in a sequence or simultaneously. It is appropriate when you have a very large variety of products or different variants of products are there. For example, there are 6 variants of, let's say, a washing machine, and they require all of those have like similar or standardized manufacturing operations for like 70% of their operations are same. What does it mean? 70% of the manufacturing is same for all the 6 models, but there is a difference in 30% of the operations. One washing machine would be totally manual, one would have some another characteristic added to it, and there would be a washing machine which is fully automated. In that one production line would have like 6 type of GTs or cellular cells with them. So every type of machine, after the standardized functions, it would go to the specific cell. So in a layout, you need to first of all identify the products that are similar in terms of processing requirements, and then to group them into a family. The next step is to pool the machines required to process one or more families into one cell. So you would have a family like, I give you an example of washing machines. So there is a family of a product which have similar characteristics, and you would pool the machines when there is some type of customization there. So cellular layouts are like dynamic layouts in a sense that you can change the composition of the cells as well. So these were the common type of layouts which you know before, but we have revisited it for the better understanding. Thank you.